Hello everyone. So now we are gonna start with our new chapter. Okay, that is fundamentals of unit and dimension. Actually, the chapter unit and dimension and error, that is little bit big. Okay, we are just gonna understand fundamental, which we are gonna use in this next chapters. Okay, just fundamentals. Okay, the unit and dimension error we are gonna study again. Okay, at the end of the all the chapters. Okay, because what happens is the terminologies which we use, okay, the terms which we use here in the unit dimension and error, a student doesn't understand that because you have not studied that things. Okay, understand? So we are going to just study the fundamentals so that we can define anything coming in our front, that we can define the unit of it and we can define dimension of it, and we can check that the formula is dimensionally correct or not correct, right? That we gonna understand here. After that, we gonna understand in unit and dimension and error, that chapter fully we will cover everything about unit dimension and error. This is just a fundamental chapter and this is not going to take much longer. Okay, so first what we are saying is that the physical quantities are three kinds of. What are they? Fundamental quantities, derived quantities and supplementary quantities on the basis of the derivation. Okay, so what are these fundamental quantities? Quantities which covers the entire span of physics, that is quantities which are defined on their own, are called fundamental quantities. Okay, so they are not derived from somewhere else, they are on their own, they are. Okay, you can't split in more dimensions. Okay, more like quantities, kind of like a mass. Okay, so like you have speed. Okay, let's take derived quantities first. Okay, derived quantity is speed. Okay, so speed you can write distance upon time, right? Distance per unit time is distance covered per unit time is speed, right? So distance is a quantity and time is a quantity, right? So you can divide. Similarly, you can't divide distance now. Length you can't divide more, right? So these are the fundamental. So what are the fundamental quantity? Mass, okay, length, time, temperature, electric current, luminous intensity. This you're gonna understand later on in whatever this is gonna come again. Okay, don't worry. Amount of substance. So amount of substance, like number of substance, number of particles. Okay, that we take in mole. Okay. Next thing is derived quantities. So derived quantities are just derived from the fundamental quantities. Okay, so speed, that is distance upon time. So distance is here and time is here. Okay, fundamental. Velocity, displacement upon time. Displacement is also a kind of length only, right? So length per unit time. Momentum, mass into velocity. So mass is a fundamental quantity and velocity is a derived quantity. So just multiplication of the two fundamental, with the help of the fundamental quantities we are deriving that. Torque is also we are going to define, don't worry about that. Okay, force, that is mass into acceleration. So acceleration we also know. So we're going to see these things. Okay, don't worry about that. Next, third thing which we have is supplementary quantities. So supplementary quantities is just after leaving fundamental and derived quantities, we have some supplementary quantities which are arc length per unit radius equals to angle. Okay, so in the first chapter mathematical tools we have defined this thing, angle, right? Theta, that is arc length divided by radius, right? If you remember, we have wrote there arc length equals to angle into angle multiplied by radius, right? R theta. So if you remember that thing, okay, this is kind of supplementary quantities. Then you have solid angle. Okay, solid angle is basically when you define for a circle. Let's understand what is solid angle. When you define for a circle, right? Circle, what you say? You have point and this is your angle, right? Around this. So this is like 360 degree, right? Okay. But if you take a sphere, if you have a in 3D, you have a sphere. Okay. So there in middle, if you take, that is a solid angle. Okay. I hope you understand. That is a solid angle. Understood? So because that angle is in 3D, not in 2D. Okay. So that angle is called as solid angle. And what is the formula of solid angle? Area per divided by radius square. Okay. So like that. Now next thing we are which we're going to define is unit of fundamental quantities. What are the units of fundamental quantities? So there are two units. One is SI unit, one is CGS unit. Okay, so this is just standard international unit which we define for every quantity, and this is we are using this thing. Okay, so for mass we define kg, and in CGS we use gram. For length we use meter, and for in CGS we use centimeter. In time we use second, here also second. Temperature Kelvin, okay. Electric current ampere. Luminous intensity CD, okay. Luminous intensity we read it, okay. Amount of substance mole, okay. Same we use here also, same thing, okay. Now let's write down some SI units of some things, okay, derived from this, okay. So first we have is our speed, that is formula of a speed is distance upon time. So this will be, distance is in meter and time is in second, so this will be meter per second, right. Velocity is also meter per second. Acceleration, change in velocity, right. So velocity minus velocity, that is velocity only, so meter per second divided by second, right. From here I took here meter per second divided by second, so this is meter per second square, right. Then we have force equals to mass into acceleration, so mass is in kg into acceleration, just we derived here, what is meter per second square, right. We also wrote it as Newton. What we write it? Newton. SI unit, both are SI unit, you can change, you can use interchangeably, okay. Next is momentum, so momentum is kg and mass into velocity, right. Formulas don't worry, formulas we gonna check one by one, this in the next chapters it's gonna come, all the formulas, you don't have to worry. Mass into velocity, okay. So here mass is what? Kg, and velocity is, we wrote meter per second, so meter per second, so this is kg meter per second, okay. Or I can write Newton second, okay. If you multiply this into second, then it's gonna come this, right. So I can write Newton second. And then we have work done, so work done is force into displacement. Force we wrote, what is that? Kg meter per second square, okay, multiply by displacement, displacement is meter, right. So this is my kg meter square divided by second square, right. So this I can write Newton into Newton meter, right, Newton meter, or I can write it joule, that we write in SI unit, okay, joule, okay. I hope this is clear, understood. Now next thing which we have is dimension. Now we are going to define dimensions of different quantities, okay. So for dimension, you see dimension is any physical quantity in its relation with the fundamental quantity. So any quantity, how it is related to its fundamental quantity, in what powers it related, we're gonna see, okay. Don't worry about that, okay. So for mass we use symbol of m. For length, what we use symbol capital L, okay. For time we use capital T. Temperature we use Kelvin K, okay. Electric current we use A, okay. Luminous intensity capital C, small d, okay, CD. Amount of substance is mole, okay, for which we use mole only, MOLE, okay. Now let's define for this, okay, dimension, okay. So previously, if you see, previously we defined SI unit, okay. This is how you write units of the different quantities. Now we are going to see how to write dimension, okay. So for displacement, if you write, displacement is a length, right, only length is there, right. So I can write it as length, okay, that's my length. So, or what can I write here? Mass power m, that is 0. So something power to 0, 1. So mass power 0, length power 1, and time power 0, right. This is how I can write. Speed, what can I write? Speed for, okay, speed I can say length per unit time, right, okay. So I can say this as mass 0, length 1, and time -1, right. It is gonna come in numerator, that it is -1, okay. Let's write on this first thing, first this area. So area is basically length square, or what can I write? Mass 0, length to the power 2, and t to the power 0, right. For volume is L cube. So what can I write? Mass 0, length cube, t 0, right, okay. So distance we already defined here, distance, basically distance is also L, right. So we can write m0 L1 t to the power 0. Okay, now let's come to the velocity. Velocity also same, so m0 L1 and t to the power minus 1. I hope this is understood. Okay, acceleration is what? Meter per second square, right? Meter per second square. So meter for 1 and second denominator, so it is gonna come in numerator, so minus 2. Okay, work done. If you see work done, what is work done? So in work done, what is there? Force into displacement, right? And force is kg meter per second square and into meter. So this is gonna come kg. So for that, mass to the power 1 and L to the power 2 and T to the power minus 2, right? Meter square divided by second square for that. Okay, torque formula I think you don't know. Okay, so for torque formula, just for time being, just hold this thing. Okay, or I should tell you torque formula. Okay, torque is basically force into displacement. You can understand, force into displacement only. Okay, for time being, you just hold it. Okay, we will study this thing. Okay, leave this thing. For force we can write, right? Force is easy. Okay, force is what? Mass 1, length 1, t to the power minus 2, right? Momentum, mass into velocity, right? Mass into velocity, so mass 1, length 1 and time minus 1, right? Power formula here written, work done per unit time. So work done we wrote, right? Work we wrote, and per unit time, so just one more time, L2 and t to the power minus 3. Okay, this is your power. And then intensity. Intensity is power unit per area. So area is L square, right? So this is gonna be come m1 L0 t to the power minus 3. This is your intensity. Okay, I hope this is clear. Now we have some things here, dimension of this quantities, angular variables. So angle is arc length, that is also a length, and radius, this is also a length. So this is kind of a dimensionless quantity, m0 L0 t0. Okay, dimensionless. Okay, and then angular displacement is also, angular displacement is basically delta theta. Okay, change in theta from here to here, so delta theta is dimensionless. Okay, same thing. And then angular velocity is angular displacement divided by time. So this is, angular displacement is dimensionless and time is, so it's gonna come in numerator, so that is m0 L0 t to the power minus 1. Okay, then we have angular acceleration, that is alpha. So angular velocity divided by time, so angular velocity is this and divided by time, so one more power t to the power minus 2. Okay, now this one note is written. Now we have one note that is written, a dimensionless quantity can have unit, but a unitless quantity can never have dimension. Okay, example of this, a dimensionless quantity can have unit. So here if you see angle is a dimensionless quantity, right? Angle is a dimensionless quantity, but it have a unit. What is the unit of angle? Radians and degree, both. Radians also have and degree also have, but it is a dimensionless quantity. But if something is we can say unitless, right? So then there is no dimension, right? If I write like that 4, okay, I didn't wrote any unit, so that dimension is also nothing, right? But so this is like this. So dimensionless quantity can have unit, but unitless quantity cannot have dimension. Okay, this is my point.